Find the general solution of the differential equation. So we have a second order linear non-homogeneous ODE. To solve this, we first consider the corresponding homogeneous. So consider the corresponding homogeneous. That means just take right hand side 0. And we know how to solve this. For we find the characteristic equation, that's r squared minus 3r plus 2 equals 0. We solve this quadratic equation for r. For we can factor r minus 1, r minus 2 equals 0. From this we get r equals 1 and 2. So e raised to 1t and e raised to 2t are two solutions, and we can write down the complementary solution. So when we consider the homogeneous, that's called the complementary solution. So yc is now c1 e raised to 1t, or just t, plus c2 e raised to 2t. Okay, now we want to find a particular solution, and the general solution will be complementary solution plus the particular solution. Okay, to find a particular solution, we just guess our yp, y equals yp, particular solution. Let's make a guess based on the right hand side. So we have e raised to 3t, the constant does not count, we don't have to worry about 5. E raised to 3t, e raised to 3t is not already a solution, so we can just keep e raised to 3t and a new constant, could be anything. Let's say a times e raised to 3t. Okay, that's our guess, and we need to determine the value of a. Okay, so y a particular solution in this way. Now we want to plug in y into this ordinary differential equation and determine a. Look at here, y prime, y double prime. So we need to find y prime. The derivative is a e3t times 3, and y double prime 9a e raised to 3t. Okay, now we want to plug these into the ODE. So 1 times y double prime, so we just multiply this by 1, let's write right hand side, minus 3y prime, we want to multiply this by negative 3, and 2y, we want to multiply this by 2, and we add. Okay, and that should be equal to 5 e raised to 3t. Okay, plug these into the original ODE, given ODE. So here is the case, we already set up in nicer way. So that's 9a e raised to 3t minus 3 negative 9a e raised to 3t and plus 2a e raised to 3t. That equals, right hand side is 5 e raised to 3t. We should be able to find the value of a. In that case, our guess will be good, and we can go ahead from there. 9a3t, 9a3t, we can cancel, positive, negative. Then we have now 2a e raised to 3t equals 5 e raised to 3t, and e raised to 3t, they are same, so 2a should be equal to 5. That means a is 5 halves. Okay, so we have the value of a, so thus we have a particular solution which is a e to the 3t, so a is 5 halves e raised to 3t, and the sum of this particular solution and this complementary solution is the general solution. Hence the general solution of the original ODE, y is y complementary yct plus particular ypt, which is c1 e to the t plus C2 e to the 2t plus we just found yp here, which is 5 halves e to the 3t. Okay, final.